table which shows that there are two offices, office A and B, and there are different products like product P and product Q. 20 is the number of units that office A has to supply, and 50 is the number of units that office B has to supply. 30 is the number of units that product P demands, and 60 is the number of units that product Q requires. Now if we see here, the total supply from two offices, office A and B, is 70 units, whereas the total demand required by different products like P and Q are 90 units. So here we will try to add a dummy row as shown in the figure below. The third row is a dummy row where we try to add 20 units of supply, which makes the demand equal to the supply. We have another example here. Here we have different supply and different demands. So in this example, we try to add a dummy column. With the help of adding this dummy column, we can reach to a stage where we have equal supply and equal demand, which is 90 units. This is the case of where supply is greater than the demand. The previous was the case where demand was greater than the supply. Moving on. Let us try to understand the different terminology used in transportational model. Feasible solution are the non-negative values of Xij which try to satisfy the constraints of supply and demand is called feasible solution. And the basic feasible solution if the number of positive allocations are m plus n minus 1. If we try to recall, here m are the number of rows and n are the number of columns. Optimal solution in a transportational model is a feasible solution is said to be optimal solution if it minimizes the total transportation cost. So in the examples associated with transportational problem, we should always try to find out an optimal solution. We have two types of transportation problems, mainly balanced and unbalanced. So a balanced transportation problem is one in which the total supply from all sources is equal to the total demand in all the destinations. In unbalanced transportation problem, the supply and demands are not equal to each other. Such problem is called an unbalanced transportation problem. The matrix terminology. In the matrix, the squares are called cells and form columns vertically and rows horizontally. By degenerate basic feasible solution, it means that if the number of allocation in basic feasible solution is less than m plus n minus 1, then it is called to degenerate a basic feasible solution. So, with any transportational problem, we can say there are two steps involved. Step 1 is to find out an initial basic feasible solution. And step 2 involves by obtaining an optimal solution by making successive improvements in initial basic feasible solution until no further decrease in transportation cost is possible. Today, we will try to understand how to reach to an initial basic feasible solution with the help of three methods. The northwest corner method. is the first one, the lowest cost entry method, also known as LCEM. Also gives us the initial basic feasible solution. And the third one is the Vogel's approximation method, also known by VAM. Now, let us try to solve a transportation problem mathematically. The first one, northwest corner method. This method is the most systematic and easiest method for obtaining initial basic feasible solution. Let us try to understand the different steps involved to solve this problem. When we are given a matrix representation of a transportation problem, we have to construct an empty M cross N matrix completed with rows and columns. Step 2 is to indicate the rows and columns totals at the end and check if the demand is equal to the supply. Let us see the step 3. Starting with 1, 1. By 1, 1 here it means the first cell which is in the top row, which is in the northmost corner of the matrix. So starting with 1, 1 cell at the northwest corner of the matrix, we start to allocate maximum possible quantity, keeping in view that allocation can neither be more than the quantity required by the respective warehouses, nor is it more than the quantity available at each supply center. After doing this, we go to step 4, where we try to adjust the supply and demand numbers in the rows and columns after allocations. In step 5, we see that if the supply for the first row is exhausted, then we move down to the first cell in the second row and first column and go to the step 4. We try to do the same thing and then we go to step 6, where we check if the demand for the first column is satisfied, then we move to the next cell in the second column and first row and go to step 4. It is highly possible that if for any cell supply equals demand, then the next allocation can be made in cell either in the next row or column according to our choice. Step 8 is to continue this procedure until the total available quantity is fully allocated to the cells as required. So to solve a transportation problem with the help of northwest corner method, there are 8 steps involved. Now, let us try to understand these 8 steps with the help of example. Here, there are 3 origins, origin 1, 2 and 3. We have 4 destinations A, B, C and D. Here, we can see that origin 1 has 7 units to supply, origin 2 has 9 units to supply and origin 3 has 18 units to supply. On the other side, the different destinations A, B, C and D require 5, 8, 7 and 14 units respectively. The numbers like 19, 30, 50 and so on up to 20 denoted in red color here represents the transportation cost associated with each unit. Now, let us try to solve this example here. These are the different transportation costs associated with each unit. Here we have different destinations: destination A, destination B, destination C, and destination D. Here we have different suppliers: supply 1, supply 2, and origin 1, 2, and 3. Here we have the supply 7, 9, and 18 units. And here we have the demand, which is 5, 8, 7, and 14 units respectively. So let us try to solve this example. The first cell, which is the cell 1, 1, here, we will try to allocate the units here. Now if you can see, at this place the demand is of 5 units and the supply is of 7 units. So we can try to completely fulfill this demand. So we shall allocate all the 5 units here, and this will have no further demand. So that makes us left with only 2 units available now at origin O1. Now because destination A does not require any demand here, we nullify this column. Now we do not take into account this column. The remaining transportation matrix is this. Again, the first cell 1, 1 is this. So we will try to allocate the units from this place. As you can see here, it has 2 units to supply, but the demand is of 8 units. So we can only fulfill 2 units of supply here, and there is no more supply. So this origin cannot give any units to different destinations like C and D. But here we are still left with 6 units of demand. So now we do not take into consideration this column and this row. In the remaining matrix, we have the first northwest corner cell is 30. So as we can see here, there are 6 units of demand and we have 9 units of supply to give, which means that we can completely satisfy the demand here by giving all the 6 units available. Which means we do not have any more demand here and we are left with 3 units of supply still from the origin 2. In the remaining matrix as shown here, we can allocate 3 units, leaving with no more quantity. We will be left with 4 more units of demand. And now it's very easy to understand that there is 18 units of supply and we have 4 units of demand here which we can give, and 14 units of demand here, which is total 18. So this is how we have done allocation of units according to its supply and demand. Let us try to understand with the help of this figure. As shown in the figure here, we have tried to solve this example. This is how we carry out the calculation. We have another example here. We have different warehouses 1, warehouse 2 and warehouse 3. And we have different plants, plant 1, plant 2 and plant 3. The different costs associated with different warehouses and different plants are given to be 769, 573 and 458. The supply is given to be 20, 28 and 17, whereas the demand is given to be 21, 25 and 19 units. So we will start allocating different units to different places, starting from the northwest corner. So as we can see, the demand is of 21 units, the supply is only of 20 units available. So we will supply all the units here, such that we will be left with no more units at plant P1. So we cannot supply anything to warehouse 2 and warehouse 3. It also means that from warehouse 1 we still have 1 unit to supply. We still have 1 unit in the demand. Moving on, the northwest corner now is this cell. It has 1 demand. The supply is of 28 units. So we'll take only 1 unit here and the demand is over. We are still left with 27 units of supply. We do not have any demand in warehouse 1. Moving on, the northwest corner now is at this place.